Okay, we'll get started in about 1 to 2 minutes. Just give a few more people the chance to sign in. Okay, so we'll get started now. Last class we had some technical difficulties, and I'm kind of just trying to think of that as kind of the equivalent of having a like a fire drill or something like that, just some kind of interruption. Sometimes that just happens. So what I thought I'd do is I would do the double live streaming that I've been doing with some of my other classes. Not only am I now on YouTube Live, I'm also on Discord. So if you like, you can head over to the Discord. I put the link in the YouTube chat. It's also on the website. So that way, if something happens to the stream again, then we can just continue on Discord. I think that Discord is fairly easy to join. You don't really need too much like software. You can do it in just a typical web browser. I think that you may have difficulty if you're just on mobile. So I think that if you have some older Android phones, you may not be able to connect. But hopefully that's it. Like you only will only need to use it as sort of a backup. Yeah, another nice thing about Discord too is that if you have a microphone, you can just shout at me and ask me a question, and it'll be live. Okay, I will ignore your name. Okay, I think I can actually change it. There we go. There we go. Okay. Just on the... there's Sean. Okay. If you it just says mark now. Anyway, if you log in and you would like a role, then maybe just send me a message and I can add you to the grade 10 advanced role. That way, if I want to like just kind of mention everybody, like, hey, I'm going live or something like that, then you'll get a little notification. Otherwise, I think that there's a way to do it yourself. I asked a student to set this up yesterday. I'm not sure if it completely worked out yet, but there's a channel called like reaction rules, and I think that you can send a message and then just automatically make yourself like in grade 10 or whatever. Anyways, you should also be able to view my screen just like on YouTube in Discord. So you don't have to have both YouTube and Discord open at the same time. Like I am streaming the video on Discord. I'm not sure which one is better quality. It's kind of hard for me to see that because the only preview that I get is just obviously my local preview, so I don't know how it looks on your screen. So if you like, you can just use Discord or you can use YouTube. What says that your Discord screen is blank? I think what you have to do is go into the grade 10 advanced audio chat. I think it's under math help, and then just click my name, and then there should be a little window saying that like Math B is streaming, and then you should be able to see my screen. Otherwise, you can just keep going with YouTube, whatever you prefer. Anyways, enough talk about that. So I think yesterday we kind of got sort of like this is where we left off. We were looking at how to graph and talk about functions or quadratic functions when the only thing we know about it is 3 points. And I got a little bit cut off yesterday, as you know. But the gist of it was this. So these points that we were given they were strategically given to us. So if we take a look at the points that we have here, you'll notice that 2 of them are on the same plane. Or sorry, not on the same plane. They're all on the same plane, the Cartesian plane. What I meant to say is they're all on the same horizontal line. So this line that I made in blue here signifies that, okay, so I've got 2 points on that same line. Okay, so that means that the axis of symmetry has to be exactly in between those, right? Because that's how quadratic functions work, is that you get this axis of symmetry that that has everything to do with the fact that a negative number squared is positive. So on the left of this, we're getting negative values of x. But then we're squaring it, which becomes positive, and then obviously our a value is probably negative, which is why it's opening downwards. But right here in the middle, this is where we get this sort of change. And the only way that you can get back where you started is if, at this point you're increasing, right? So we're increasing, and then all of a sudden we have to be decreasing, and that's going to happen right in the middle there. So I thought that was an important question to answer. And if we only had 2 of these points, like if we only had these points, well, sure, we could find the axis of symmetry by saying it's right in between these 2 points, but we wouldn't have been able to say whether or not it went upwards or downwards, right? The reason we were able to say that it goes downwards is because I know that the axis of symmetry is here, but then I also have this other point, -8, -3, which is over here, and that can only happen if this point is connected with that point, and then the axis of symmetry tells us that over here we have to start going down. So So yeah. Okay, so I want to just do a few more examples today, and then I want to talk about an assignment that I've got coming up for you guys. You know what? Actually, I'm going to talk about the assignment first. I'll just talk about it first because so I looked over the CrowdMark sort of assessments and like that test or sort of trial run with CrowdMark, and it seemed as though there was sort of like a resounding opinion that we don't want to use CrowdMark. It seemed like it was maybe a bit of a pain in the butt to log in, and every single question you had to take a new picture, and it just seemed like it was probably more work than it's worth. So I thought we would just keep it simple and use a platform that we've already used. A few students, quite a few students actually, pointed out that you're already on Google Classroom. So I think that that works perfectly then. So we'll just use Google Classroom, and that's how I'm going to provide feedback, is through Google Classroom. So I think that Google Classroom, I've never used it before, so the quality of the feedback might not be as good as CrowdMark. I really like the fact that I could give you check marks, and like with my iPad I could mark up your assignment and everything. I don't think I can do that with Google Classroom. I think really all I give you is just a grade. So the way it's going to work is I'm basically just going to have a Google form, and that will just have several questions. Some of them might be multiple choice. Some of them might be kind of like, I don't know, like a short answer, like punch in a particular number, like where the answer is just 43, and then right away you'll be able to know if you got it right. And then I would like to do one sort of long answer question where you would actually have to photograph your work, and Google Forms allows you to do that as well. So if you have any difficulty photographing your work, let me know, and we'll make some kind of arrangements for you. But I think it oh, I invited you to teach the Google Classroom. Oh, brother, what a rookie move. Okay, let me go to Google Classroom then. Okay, so you guys are all teachers, and I have one student. Okay. Yeah, okay, so I'm going to have to sort of fiddle around with... oh yeah, you guys are all teachers. Shoot, I'm sorry. So I'm going to have to remove all of you guys. So this teacher won't be able to open this class unless we're invited. Yeah, that's fine. So I'm not going to do that right now, though. Yeah, my bad. Thanks for pointing that out. I'll fix that today. Yeah, I'll add you as students later today. So yeah, so the way the assignment is going to work in terms of due dates, I think I mentioned a couple times that I really don't want to give you like a whole bunch of work over March break. That said, I do want to squeeze in one little assignment, sooner rather than later. So, and I've kind of been trying my best to sort of get this to you as soon as possible, but there's just been a lot of sort of technical difficulties that I've been facing with assignments. So, the way it's going to work, and if you have any sort of issues with the due dates, then let me know. I'm going to post an assignment today on our Google Classroom, and I'll make it available on our website as well. I'll just make it available on all the platforms, so you don't have to feel like you're missing out on certain platforms. And I'm gonna make it due on Monday. Okay, so so Monday is going to be the day that your next assignment is due. And I realize that means that we are going to have to dig into our March break a little bit, but we'll kind of think of it as like your March break starts on Monday, because it's like technically like the first day off is Monday, right? Like March break is 5 days. It's the Monday through Friday. So we'll work through the weekend, and I'll try not to make the assignment too bad. But I do want to definitely challenge you. So the assignment due date will be a Monday, and that'll give you the weekend to work on it. And I'll do my best to make myself available over the weekend. So if that means like maybe just like me going live for just a short little while to answer questions, I might do that. But in general, like if you just have a question, just send me like an Instagram message or something, or a Discord message, and I'll do my best to get back to you right away. Okay, yeah, and then the content is going to be just a little bit on exponential functions. Like we didn't dig too deep into exponential functions, so I like don't freak out. I'm not going to ask you like super challenging questions about exponential functions. I'm going to ask quite a bit about quadratics, like factoring quadratics, calculating roots, and that kind of thing. And then, and that's, yeah, I guess that's pretty much it. I might just for the fun of it throw in a question or two on sequences and series. Not like a crazy hard one, but I want to make sure that we're still thinking about some of the previous topics. So, okay, so I'm gonna do this question now. So we've got this function. It's in this would be vertex form. So it looks like the vertex. So the part one, we've got the vertex. So let's talk about what the vertex is. The vertex is going to be the point. 1, 4. Okay, so here's my point 1, 4. 1, 4. I know that it's 1 because I'm subtracting 1 here and I'm adding 4 here. So that's where I get those numbers. Number 2, I'm asked for the axis of symmetry. The axis of symmetry is just going to be the x value there. So the axis of symmetry is just the line x equals 1. 3, the y-intercept. So the y-intercept occurs when x is equal to 0. So when x is equal to 0, I'm going to get 0 minus 1, or so I should say negative 0 minus 1 squared plus 4. So I've got negative 1 squared is positive 1, but it's negative because there's a minus sign up front. So I've got minus 1 plus 4 equals 3. So the y-intercept is the point 0 and 3. Okay, the x-intercepts. So here we're actually going to solve the equation. So I'm going to set y equal to 0. So I'll do that right over here. So when y equals 0, we get that 0 is equal to negative x minus 1 squared plus 4. Okay, then I'm going to move the 4 to the other side. So we've got negative 4 is equal to negative x minus 1 squared. Next up, I'm going to multiply both sides by negative 1, so I don't have any negatives anymore. So now I get 4 is equal to x minus 1 squared. Then I'm going to take the square root of both sides. So the square root of 4 is 2, so I get plus or minus 2 is equal to x minus 1, and that means that x is equal to 1 plus or minus 2, so that means x is equal to either 3 or negative 1. So my x-intercepts are 3, 0, and negative 1, 0. Okay? The domain of f. So the domain is just going to be the set of all real numbers, right? Because with a quadratic function, there's no values that x isn't allowed to take on. So that's everything. The range of f. Okay, so let's think a little bit about what the graph is going to look like. So I know that this is the vertex here. So my vertex is 1, 4, and I'm pointing downwards, which means that if I'm pointing downwards, my vertex is going to represent the maximum value, okay? And the maximum value is going to be, well, the y value of the vertex. So my range is going to be all values of y, right, that are less than or equal to the y value of my vertex. So the range is going to be, and I'll put it in both interval and set notation. So let's start off with interval. So because I'm talking about a maximum value, there's no minimum value. So I'm going to start off at negative infinity. And remember, we use a round bracket because we never include infinity, because infinity isn't a value. Remember, it's more like a direction, right? Like we're pointing towards infinity. It's like north and south. Like you don't actually like have a, like north is not a value, it's a direction. It's like left and right. Those aren't values, so those are directions. Negative infinity, think of it like a direction. So we start off at negative infinity, and then our maximum value, what did I say, was 4. And because, hey, look, here's a point that actually has 4 in it. So we obviously have to include 4 because our vertex actually has that point. So that's interval notation. And in blue, I'll write it in set notation. So in set notation, we're talking about all values y such that y is less than or equal to 4, because 4 is our maximum value. And then we also need to specify that we're talking about real numbers. So I'm going to write y is a real number. Okay? And then our maximum value, well, we already kind of figured that one out. So our max value is y equals 4. Okay. So that's that question. So that's pretty much like that's fairly exhaustive in terms of questions that you would ask about a particular quadratic. So yeah, let's move on to another question. I thought there was something that I wanted to. Oh yeah, there is one thing that I want to point out. Oh, and we also have to graph it. That's kind of like the most important thing. So let's graph this one. So if I've got a vertex at 1, 4, that means that my vertex is going to be at 1, 1, 2, 3, 4 right here. Okay, my stretch factor is -1, right? Because it's just a negative right there. So that means it's going to be like I'm going to go over 1 and then I'm going to go down 1 instead of up 1. I'm going to go over 2 and then down 1, 2, 3, 4, right? And I do that in both directions. Okay, I could probably squeeze in one more point. If I go over 3, 1, 2, 3, I'll go down 9 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So there's my parabola. Oops. There's my parabola, and I'll just zoom in here to make sure that I get a nice smooth line. Okay, and there's my parabola. Okay. And you know, I should also point out that you might find it easier to graph the parabola before you start talking about things like the domain and the range and the max value. Also, now that I've graphed it, I can see right away that this is consistent with the x-intercepts that I found. Right, I've got an x-intercept at 3, 0 and -1, 0. So here's 3, 0. Here's -1, 0, right? So it is all consistent, so this all makes sense. Okay, so looks like the chat is pretty quiet, so no questions so far. Okay, let's do this one. I think this is a good question as well. So by the way, I think it's important that that you're following along with these questions and that you're writing them down. I'm not sure if you all are doing that, but it's much more useful to actually partake in the activity rather than just to watch it. I know that it's tempting just to sort of sit back and maybe you're drinking a coffee or something, or a tea, or having some Fruit Loops or whatever. But it is important to actually, use a pencil and partake in the activity that I'm doing, and that it's not all just like osmosis and just kind of watching someone else do it, but to actually partake in it. So in that vein, what I would like us to do now, and I think that what I need to tell you what these different parts are. So I'll just copy and paste this. Oops. Whatever, it's a little bit stretched. So I'll just do this. Okay, done. It's a bit squished, but whatever. And then I'll do this, and I'll paste it in like so. Oh, and then here it didn't do it anyways. Okay, so then I'll crop this. Okay, and I want you to try this one, okay? So I'm going to give you maybe 5 minutes to work on this one. And I know that you don't necessarily have like graph paper next to you, but I hope that you do have graph paper. But if you don't, it's not the end of the world. So I'll make this nice and big for us to see. I guess you don't need to see the graph quite yet. So these are the things I want you to answer. So I'm going to give you 5 minutes to do that. I'm going to set a timer, and I think I can even set a timer that you can see. Hold on a second. There we go. Look at that. Okay, so I'll set a timer for 3 minutes. Okay, and I'll do this. And then I'll do this. Okay. Okay, so I'll reset it. Done. And then I'll tell you to start. Oops. Oh, brother. There we are. Okay, so 3 minutes. Tell me the vertex, the axis of symmetry, the Y-intercept, the X-intercepts, the domain, the range, and the max and minimum value. Okay, I think that's 3 minutes. So let's try to do this one together. Okay. So what we're gonna do is let's start off with a vertex. So I mean this question is in vertex form, so this one should be the most straightforward. So this is gonna be the point 2, negative 3, right? Because I'm subtracting 2 and then I'm adding negative 3. Okay, so number 2, the axis of symmetry. So that is going to be the line x equals 2, because that's our x value of our vertex. 3, the y-intercept. So when x equals 0, I'm going to get that y is equal to 3/4 times 0 minus 2 squared minus 3. And that gives me y equals 3/4 times negative 2 squared minus 3. Or in other words, well, 3/4 times 2 squared. 2 squared is 4, so 3/4 times 4 is 3. So y is equal to 3 minus 3, so y is equal to 0. So we have a y-intercept at y equals 0. So I've got the y-intercept at 0, 0. Okay? So that's kind of cool because it also tells us what one of the x-intercepts is, right? 0, 0. Okay, so number 4, let's find the x-intercepts. So we've got, I'm going to set y equal to 0. So now 0 is equal to 3/4. 3/4 times x minus 2 squared minus 3. And let's start solving that. So this is all equal to 3 equals 3/4 times x minus 2 squared. I'm going to divide both sides by 3/4. So in other words, multiply by 4/3. And I'm going to get 4 is equal to x minus 2 squared. Or in other words, plus or minus 2 is equal to x minus 2. And then I'm going to add 2 to both sides. So x is equal to 2 plus or minus 2. So x equals 2 or x equals, sorry, not 2. X equals 0 or x equals 4, depending on whether or not you added or subtracted. Okay, so let's write those. So we get the point 0, 0, and the point, well, when x is equal to 4, y is equal to 0. Okay, so that's that. So I've got my y-intercept, my x-intercepts. The domain of f, the domain is always going to be the set of real numbers. The range of f, well, it looks like we're opening upwards like this, which means that this is going to be a minimum. The vertex is going to be a minimum. The y value of the vertex is negative 3. So I've got negative 3 as my minimum value. So I've got negative 3, and I go all the way to positive infinity. And I made a little mistake here. This should be a square bracket because we do include negative 3. Okay, so that's that. Number 7, so the maximum and minimum value. So the there is no maximum value because this thing goes off towards infinity, but the minimum value is, so I'll write minimum val is y equals negative 3. So that's the smallest we get. And when we graph this, let's graph it over here now. I'm going to start off with a vertex. The vertex is the point 2, negative 3, so right there. And well, I've got my 2 points here, my x and y intercept. So there's my x and y intercept there, and then I've got another intercept at x equals 4, and that's pretty much all I need. So it's going to look something like this. So there's my parabola, and we're done. That's it. So I only gave 3 points there, and again, this is looking a little pointy, but if we really were to zoom in, it would be nice and smooth. So just make sure that when you're drawing these that it is nice and smooth. Okay, so that looks good. That's pretty much it for that question. Let's do another one. Okay, let's find the number of x-intercepts for the quadratic function, and we're not going to do all of these. I only want to do a couple of them. So the number of x-intercepts. Okay, so what we're going to do here is so we're going to start solving for them. So I'll do part A here. So if it's an x-intercept, then f of x is equal to 0. So I've got 0 equals -2. I'm going to make my pen a little bit thicker, actually. That should be better. Okay, so I've got 0 is equal to -2 times x minus 1 squared plus 1. Okay, and if I bring the 1 to the other side, I get -1 is equal to -2 times x minus 1 squared. And when I bring the 2 over, I'm going to get 1/2 is equal to x minus 1 squared. Now, if I take the square root of this, I'm going to get two solutions, right? I will get plus or minus the square root of 1/2 is equal to x minus 1. So we don't have to actually solve for it. All this tells us is that there are two x-intercepts because we get a plus and a minus. Okay, let's do part C now. I want to do part C. So this was A. Part C is okay. So let's say I've got okay. So I've got 0 equals -2x times x minus 1 squared. Okay. Okay, so that looks good. So now what I'm going to do is I'm going to divide both. Oops, that's not x. That should be like this. Okay. Okay, so that looks a little bit. Oops, I don't know what I did there. Okay, I guess that's better. Okay, so I've got 0 is equal to -2 times x minus 1 squared. So I will, I'll bring the 2 to the other side. So I've got, well, 0 divided by -2 is still just 0. And that's equal to x minus 1 squared. And maybe you can start to see where this is going. If I take the square root of 0, it's just going to be 0. It's not plus or minus 0. It's just 0. The square root of 0 is just 0. So I have that 0 is equal to x minus 1. This gives me exactly one solution. Just one solution. Okay. So I'm going to give you, I'm going to do another thing where I give you 1 minute. I want you to answer B and D. Okay. So I'm going to give you 1 minute to do B and D. So here's 1 minute, and we'll start right now. So get your hands dirty, try these ones out, see how you do. Okay. So this first one, let's do B together. I'll do it in blue. So how many x-intercepts does this one have? Well, if we set g of x to be equal to 0 and then try to solve for x, let's see what happens. So I've got 0 equals -2 times x minus 1 squared minus 1. If I bring this 1 to the other side, I'm going to get 1 is equal to -2 times x minus 1 squared. And then if I divide both sides by -0.5, or sorry, -2, I'll get negative 1/2 is equal to x minus 1 squared. Now, if I try to take the square root, I'm going to be taking the square root of a negative number. Okay, so in other words, x minus 1 is equal to the square root of negative 1/2. Not okay. Okay, so here we have no real roots. Okay, and I say no real roots because if we wanted to, we could factor out the square root of negative 1 and say that it's I, in which case we would have a complex root. But in this case, we have 0 real roots, or in other words, 0 x-intercepts for this quadratic function. Okay, and this next one here, I'm just going to do very quickly. It's pretty much going to be exactly the same thing because this is going to be positive, so when I bring it over to this side, it'll be negative, and then I'll divide that by 2 from here, divide by 2, so I'm going to end up getting the exact same equation. It'll be negative 1/2 is equal to x, well in this case it'll be x plus 1 squared. It doesn't really matter what's going on inside the brackets because when we take the square root, I'm going to be taking the square root of a negative, so this one also has 0 real roots. So those are the 3 possibilities for quadratic functions. They could have 1 x-intercept, they could have 2 x-intercepts, or they could have no x-intercepts. Okay, what next? Okay, so let's do these 2 questions. So we're going to write the equation of a quadratic function h of x that has the same shape as f of x equals negative 1/2 x plus 1 squared minus 3, and the same vertex as g of x equals 2 times x plus 2 squared plus 1. Okay, so let's talk about f of x. So f of x has shape defined by its a value. And that's not apostrophe, it's a value. A equals negative 1/2. Now let's talk about g of x. So g of x has vertex negative 2, positive 1. Okay, so our function, I'll do that in pink, let's say, our function, and we're calling it what? H of x. H of x will therefore have vertex negative 2, 1, and shape defined by a equals negative 1/2. So in other words, h of x is equal to, well, negative 1/2 times x, and what's the x value of our, so x plus 2 plus 1. Oh, and don't forget that squared. So there we have it. There's our function h of x. So it has the same a value, so it's going to have the same shape as the first function, and it'll have the same vertex as the second function. That's cool. So I would like you to try question 7 now. So it's your turn to try question 7. So give this one a shot. I'm gonna give you 1 minute for that one. So here's the timer again, and we'll do 1 minute and get busy. Let's do this one together now. We'll just do it really quickly. It's pretty much the same question as before. So, so if it has the same shape as this first one, well then that means that A is equal to 2/3. And if it has the same vertex as the second one, the vertex is going to be -3, comma, -4. Okay, which means that our h of x is equal to, well, 2/3 times x plus 3 squared minus 4. There you have it. Okay, let's see here. I think I've just got a couple more questions left. Let's see, got that one. Okay, maybe a few more. I don't know if we're actually going to have time to cover all of these, but we'll do as many as we can. I wonder if I actually want to do this one. I don't think it'll really help us too much. I'm just trying to choose the best ones that... Aha, okay. Okay, I really like these questions here. So what I'd like you to do is I'm going to give you a few minutes to try these ones, and then we'll do them together. I'd like you to try number 4. I'd like you to do number 6. And 7. Okay, yeah, I want you to do those questions there, 4, 6, and 7. Okay, so since there's so many questions, I'm going to give you a full, let's say, 4 minutes. So we're going to do 4 minutes there, and when the 4 minutes is up, then we'll do these questions all together. You know, maybe I'll make it 5 minutes because these are actually there's three questions. So so I'll give you 5 minutes starting now, and good luck, and we'll do them together. Okay, here we go. I just noticed someone in the chat pointed out that I haven't yet posted the solutions to the most recent homework set. I'm just going to post that online right now before I forget. I'll put it right beside the actual homework set, so if you're looking for it, it's going to be just right beside the button to access the other homework set. So let me just get the link right now. Grade 10, quadratic function solutions, copy link, do this. Okay, and then I'll insert a little button. Okay, there we go. And we got March 25th, homework solutions. There we go. Okay, so it's on the website now. Sorry that I forgot that. If you're ever expecting a document, don't ever hesitate to reach out. A lot of the times, sometimes what I'll do is I'll have my assignment, my website all updated and everything, and then I just forget to hit the publish button or something like that. So just don't ever hesitate to remind me to do something. I don't like to brag about it, but I mean, because it's not something to brag about, but I am very forgetful. So definitely, if there's something that you're expecting me to do and I haven't done it yet, never think that I'm sort of I'm not wanting to give it to you or something. It's probably just that it slipped my mind. So yeah. So anyway, so let's answer these questions. So let's start with number 4. So if a parabola has x-intercepts a and b, what's the x-coordinate of the vertex? Well, let's say that I've got an x-intercept here and an x-intercept here. Well, kind of like what I was talking about at the very beginning of class today, is that, I mean, depending on whether or not it goes up or down, but let's just say that it goes down in this case, like it's facing downwards. We're going to have some kind of relationship here, and because they both hit the x-axis right there and there, that means that the vertex, or the axis of symmetry, has got to be right in between those. So in order to calculate the midpoint of 2 points, what we would do is we just take their average. So the x-coordinate of the vertex is going to be, well, it'll be x equals b minus a over 2. So the difference between them divided by 2. So if this one is a and this one is b, we take their average. Hold on a second. Sorry, b plus a. My mistake. We add them together and then we take their average. I was just thinking because one of them is negative. But yeah, so yeah, we add them together and we take their average. So that's what we would do, is we just take their average. So the x coordinate of the vertex is going to be their average. So number 6, so determine the quadratic function f with zeros -2 and 6 and range y is less than or equal to 4. So let's just quickly sketch like a very rough diagram of this. So I've got the points -2 and 6 as the x-intercepts, and the range is everything that is less than +4. So that means that we have no values over here. So there's nothing going on over here. So the cool thing about this is that we know that the vertex is going to be like right in the middle of these 2 points. So we can find the x-coordinate of the vertex, and also because we know the sort of the maximum value, we know the y-coordinate of the vertex. So the vertex is going to be the point. So the vertex is the point. What am I trying to say? Y okay, so the x-coordinate of the vertex is going to be the average of these 2 points. So I'm going to add 2 and 6 together. That gives me positive, or negative 2 and 6 gives me positive 4. Divide by 2. So 4 divided by 2 is 2. And the y-coordinate is going to be 4. Okay, so that's good. Well, what about the rest? What about the rest? Well, let's solve for the rest. So I know that my quadratic function is going to be f of x equals. Now the only thing I don't know about this function is the stretch function is a, right? But I know everything else. I know the vertex. So it's going to be a times x minus 2 squared plus 4. Okay. Now I'm going to turn this into a y because it'll just work a little bit better. I know one of my points. I know this point. So this is the point negative 2, comma 0. So I know that when x is equal to negative 2, y is equal to 0. So we can use that fact and solve for y. Or sorry, solve for a. So if x is equal to negative 2, y is equal to 0. So I get that 0 is equal to a times x. Well, x is going to be negative 2 here. I got negative 2 minus 2 all squared plus 4. That gives me that, 0 is equal to a times negative 4 squared plus 4. Bring the 4 over to the other side. So I get negative 4 is equal to a times, well, negative 4 squared is positive 16. So that means that, a is equal to negative 4 over 16, or in other words, a is equal to negative 1/4. So now I've solved for a, so that's what a is, and I'll just write it right here. It's negative 1/4. Okay, question 7. So determine the quadratic function with f with points negative 3, 5, and 1, 5, and range y greater than or equal to negative 2. Okay, so similar situation here, except now this is not x-intercepts. It's just 2 arbitrary points. So I've got negative 3 and 5. So I've got negative 3, 5, so something like this. 1 and 5 like this. And the range is everything greater than negative 2. So nothing over here. So there's no values over here. So again, we can find the x-coordinate of the vertex. Is going to be right smack dab in the middle here. So whatever value that is. So the average of these 2 points. And the only reason this works is because they both have that 5 in them. Okay, so we have some symmetry there. So my vertex is going to be right here because I know that it can't be any lower, right? So that y equals negative 2 is the minimum value. So that means our parabola is going to look something like this. Okay, something along those lines. Okay. So let's find the vertex. So the vertex is going to be the point. Let's see. Just want to make sure no one is hollering at me on the Discord or anything. Okay. The vertex is going to be the point. Well, let's take the average of these 2 points. So negative 3 plus 1 divided by 2. So that's going to be, well, negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. So that's the, I shouldn't say the vertex, that's the x-coordinate. I'll call it the x-vertex. It's not actually what we call it, but I think you know what I mean. So the x-coordinate of the vertex is negative 1. Let's call it the y-vertex, even though this is not what we actually call it. I'm just kind of running out of room and running out of time, so I'm trying to just go as quickly as I can. So the y-coordinate of the vertex is going to be negative 2. So the vertex is going to be negative 1, negative 2. Okay, so, and we'll do the same thing again. And this time I'm just going to write it up here because I'm running out of room. So I'm going to say that y is equal to a. A is the last value that I don't have. It's the value that we need to solve for. But it's going to be a times x minus negative 1, or x plus 1 squared minus 2. Okay, and just like before, we can choose either one of these points and use it to solve for a. So let's use this one. So when x is equal to -3, y is equal to 5. So let's say that 5 is equal to a times, well, x is -3 plus 1 squared minus 2. And now we'll just solve for a. So I'm going to add 2 to both sides, so that gives me 7 equals a times -3 plus 1 is -2 squared. So 7 is equal to 4 times a, or in other words, a is equal to 7 over 4. Finally, that gives me that our function f of x is equal to 7 over 4 times x plus 1 squared minus 2. Okay, so I know that I went really quickly there, but we were just a little bit pressed for time. And I know that I went a little bit over. I hope that's okay. In any case, stay tuned for the assignment. I'll post it on all of the platforms that we're on. So that'll be the website. I'll put it on Discord. I'll put it on Google Classroom. I'll just make it available everywhere that we have any kind of online communication. So yeah, if you have any questions over March break, don't hesitate to reach out and ask a question or just say hi, anything like that. If you want to see the cats, I'll send you a cat picture. I hope that you guys have a good rest. I know that there's a lot of stress going on in the world. Whether or not you feel that stress, I don't know. That's kind of that's your own story. I know that over here, I'm starting to feel a little stir crazy. I have only left the house to drive my wife to work. She works at the Health Sciences Center, so she's deemed an essential worker because she's in healthcare. So I drive her to work every day, and I pick her up because I don't really think it's a good idea for her to be taking taxis and stuff because we don't really want to spread this virus. We want to do everything we can to do our part. And I mean the whole world is just so strange right now, and I hesitate to talk about it because I know that I'm feeling like my own mental health is affected by just the overload of information. I can't stop thinking about this darn coronavirus and COVID-19. It seems like everywhere if you turned on the radio right now, I promise you that you would be hearing something about COVID-19. If you go to Reddit, I guarantee you that on the front page there will be at least half of the posts are about COVID-19. If you go to Twitter, I guarantee you that anything trending is going to be on COVID-19. It is really hard to avoid hearing all this stuff about COVID-19, and it's stressful. It's really stressful. It's scary. There's a lot of uncertainty. So I guess my advice to you, and it's kind of ironic because here I am talking about COVID-19, and I've done my very best not to talk about it, and it's actually taken quite a bit of effort because it's really on the forefront of my mind, and I think it's on the forefront of a lot of people's mind. But my advice to you is to think a lot about your mental health. We're stuck inside, so really our natural tendencies when we are stuck inside is nowadays to go on the internet and go on YouTube and this and that. But just maybe think about trying to take a break from news sources and stop thinking about it if you can. It is kind of one of those things that as long as you're doing your part and kind of minimizing the spread in all the small ways that you can, I think that's all that you can ask of yourself. You don't have to follow every single news story. You don't have to keep track of every little thing that's going on, unless that's something that you're really interested in. But I know that for me, it really stresses me out, and it's one of those things that I'm trying really hard to kind of distance myself from the news and all of that. So anyway, I hope that you guys have a good break. It's nice to sort of hear this on the chat too. And if, like I said, if you need to reach out about something, or if you just want to say hi, then just send me a message and we'll get back to you. Yeah, stay tuned for the assignment, and I'll just Goose wanted to say hi one last time before the break, so say hi to Goose, and yeah, have a good break, and I'll see you I guess in about 10 days, or I guess you'll see me in about 10 days. Okay, take care, guys.